All right, today we're going to prove that if the diagonals of a quadrilateral bisect each other, then opposite sides, or the other word for that would be non-adjacent sides, of the quadrilateral are congruent. So first of all, what do we mean by that? We mean that if the diagonals, and those are the two lines that go through the middle of the quadrilateral, if they bisect each other, which means they cut each other in half, so that means, for example, that the distance from E to C is the same as the distance from E to A, that this diagonal here, BD, cuts AC into two equal-sized pieces, cuts it in half. And of course, the same goes for E to B is the same as E to D, because diagonal AC cuts BD into two equal-sized pieces. Right? So if they're congruent, then opposite sides, which is DC and BA, then those must be congruent, or AD and BC. And again, the way we're going to go about this is pretty much what we've been doing, is we're going to prove that two triangles, and that's these two in particular, ECD and EAB, we're going to prove that those two triangles are congruent. And of course, once we know that they're congruent, then we know all the corresponding parts match up and are congruent. And then DC and AB are corresponding parts of those two triangles, so those must be congruent. So we got to show that the two triangles are congruent. Then, once we know they're congruent, we're going to conclude that, well, therefore, these particular parts of the triangles are also congruent, corresponding parts of congruent triangles. So we'll start out with, like I said, EA and EC, that those are the same, and that's just given to us because we were told that the diagonals bisect each other. And then we've also got that BE is congruent to ED, and that's also just given to us. Okay. Now we need this extra little fact here that these two angles here, that those are also congruent. So we're going to say CED, angle CDED is congruent to BEA. And that is what we call vertical angles. Right? So vertical angles, anytime two lines cross, the angles that are directly across from each other, those are referred to as vertical angles. Don't ask me why. And they are congruent. They're the same size. Right? So these two on the other side here would also be the same size as each other. Right? Vertical angles. And now we know that EC matches AE. These two angles match, and then EB matches ED. So we have side matching side, angle matching angle, side matching side, or side angle side. And that's enough to know that the two triangles are congruent. So we have, and this is important, we have to name the triangles correctly. We'll go BEA. BEA is congruent to, and the second triangle has to be named with the vertices in the same order as the first one. So notice how we traveled down the down angle, the side that's marked with one tick mark, right? Down to the middle. So the next one has to travel the same direction from D down to E and then on out. So B down the one tick mark side, out the two tick mark side. So DEC will be the other triangle. All right, and that's by side angle side congruence. And then, if that's true, then side AB, right, must be congruent to side DC, right, because they are, both kind of the long sides of the triangle out there, the outside sides, the corresponding sides. You look here, AB, those are the first and last letters in the name, and DC, first and last letters in the name. So since we named them correctly, we can see, based on the names, that those segments are matching. They're corresponding. So they're congruent, and our reason is corresponding parts of congruent triangles are congruent, which we don't want to write out, so we just use that abbreviation there. Okay? All right, there you go.